When dealing with installations involving more than 30 current-carrying conductors bundled together within a panel board, especially when those bundles extend beyond 24 inches, the question of whether or not derating is required arises. This involves a careful examination of several articles within the National Electrical Code, specifically Articles 312.8, 366.22b, 376.22, and 310.15b2, along with understanding how a panelboard is classified under the NEC. Article 312.8 addresses the use of enclosures for switches or overcurrent devices for raceways. It states that the wiring space within these enclosures isn't intended for conductors unless they are used for connection to the equipment within the enclosure or for continuing to other equipment. While it allows for the enclosure, such as a panel board, to be used as a raceway in this limited manner, the crucial point is that this doesn't automatically classify the entire panel board as a raceway for the purposes of conductor derating calculations. Articles 366.22b and 376.22 both reference the threshold of 30 current-carrying conductors. These sections generally pertain to cable bus and metal cable tray installations respectively. They specify that when the number of current-carrying conductors exceeds 30, the ampacity of the conductors must be derated according to the tables and provisions outlined in Article 310.15b2. This derating is necessary to account for the increased heat generated by the bundled conductors, which can lead to insulation degradation and potentially unsafe operating conditions. Article 310.15b2 provides the specific guidelines for adjusting the ampacity of conductors based on the number of current-carrying conductors bundled together. This section includes tables that provide derating factors to be applied to the allowable ampacity of the conductors. These factors reduce the allowable current the conductors can carry safely, thus preventing overheating. The core of the issue lies in determining whether the conditions within a panelboard, specifically with bundled conductors exceeding 24 inches in length and numbering more than 30, necessitate treating the panelboard as an equivalent to a raceway or cable tray for derating purposes. The NEC doesn't explicitly define a panelboard as a raceway in the context of these derating requirements, even though Article 312.8 allows limited use as such. However, the underlying principle behind the derating requirements in Articles 366.22b, 376.22, and 310.15b2 is the management of heat generated by multiple current-carrying conductors in close proximity. If the bundling of conductors within a panel board creates a similar condition to that found in a cable tray or cable bus with more than 30 current-carrying conductors, where heat buildup is a concern, then it is reasonable to apply the derating factors outlined in Article 310.15b2. To determine whether derating is required, consider the following factors. Firstly, the number of current-carrying conductors bundled together. If it exceeds 30, it triggers the potential need for derating. Secondly, the length of the bundled conductors. If the length exceeds 24 inches, it exacerbates the heat buildup. Thirdly, the ambient temperature within the panel board. If the panel board is located in a high ambient temperature environment, the need for derating is increased. Fourthly, the type of conductors used. Conductors with higher temperature ratings may be less susceptible to derating. Fifthly, the load in the conductors. If the conductors are continuously loaded at or near their maximum ampacity, the need for derating is greater. To practically apply these considerations, one must follow a step-by-step approach. Firstly, identify all current-carrying conductors within the panel board that are bundled together and exceed 24 inches in length. Secondly, count the total number of these current-carrying conductors. Thirdly, if the count exceeds 30, consult Table 310.15b2 in the NEC. This table provides adjustment factors for the allowable ampacity of conductors based on the number of current-carrying conductors in a raceway or cable. The table provides derating factors based on the number of current-carrying conductors. For example, if there are 31 to 40 current-carrying conductors, the adjustment factor might be 80%. This means that the allowable ampacity of each conductor must be reduced to 80% of its original value. Fourthly, determine the allowable ampacity of each conductor before derating. This is based on the conductor size and insulation type, as specified in the appropriate ampacity tables in the NEC, such as tables 310.16 and 310.17. Fifthly, multiply the allowable ampacity of each conductor by the adjustment factor obtained from table 310.15b2. This yields the derated ampacity of the conductor. Sixthly, ensure that the derated ampacity of each conductor is sufficient to carry the load it is intended to serve. If the derated ampacity is insufficient, then the conductor size must be increased or the number of conductors must be reduced. For example, suppose you have 35 current-carrying conductors bundled together in a panel board, each with an initial ampacity of 30 amps. According to table 310.15b2, the adjustment factor for 31 to 40 conductors is 80%. The derated ampacity of each conductor is therefore 30 amps multiplied by 0.80, which equals 24 amps. If each conductor is required to carry a load of 25 amps, then the derated ampacity is insufficient, and you would need to increase the conductor size to one with a higher initial ampacity or reduce the number of bundled conductors. It's important to note that the NEC provides some exceptions to these derating requirements. For example, Article 310.15b3 allows for the ampacity adjustment factors not to apply under certain conditions, such as where the conductors are installed in raceways having a length not exceeding 24 inches. However, these exceptions are narrowly defined and may not apply in many panelboard installations where conductors are bundled for longer distances. In addition to the ampacity adjustment factors, it's also crucial to consider the temperature rating of the conductors and the terminals to which they are connected. Article 110.14c specifies requirements for the temperature limitations of conductors. This section states that the temperature rating associated with the ampacity of a conductor must be selected and coordinated so as not to exceed the lowest temperature rating of any connected termination, conductor, or device. For example, if a conductor has a temperature rating of 90 degrees Celsius but it is connected to a terminal with a temperature rating of only 75 degrees Celsius, then the ampacity of the conductor must be based on the 75 degrees Celsius rating. This ensures that the connections and devices are not subjected to excessive heat, which could lead to failure. The NEC also provides guidance on the proper installation and support of conductors within panelboards. Article 312.5 outlines requirements for the wiring methods used in enclosures, including panelboards. This section specifies that conductors must be securely supported and arranged in a neat and workmanlike manner. Proper support and arrangement help to prevent damage to the conductors and ensure adequate airflow, which can help to dissipate heat. In summary, determining whether conductor derating is required in panelboards with more than 30 current-carrying conductors bundled for lengths exceeding 24 inches involves a careful analysis of NEC Articles 312.8, 366.22b, 376.22, and 310.15b2. While a panelboard is not automatically classified as a raceway for derating purposes, the underlying principle of managing heat buildup must be considered. By evaluating the number of conductors, the length of the bundle, the ambient temperature, and the conductor type, and by following the step-by-step approach outlined in the NEC, electrical professionals can ensure that conductor ampacities are properly derated to maintain safe and reliable operation.